Hi guys, it's good to be back here on this channel, Mathematics Appreciation. Today we'll be talking on the topic indices. And here on the board we say that indices is the plural of the word index. The other names, synonyms for index are, you can call it exponent, power, or you can call it order. So these three words are words you can use synonymously to mean the same thing as index. So for us to be able to really understand indices as a topic, we really need to go into understanding of the laws of indices. These are the laws that helps us to manipulate any expressions that has to do with indices. And in fact, we can say that indices is the bedrock or engine room of algebra. So let's go to laws of indices. Number one here, we say that if we have a certain number, say a, be raised to the power of 0, it means that that value is equal to 1. In other words, we have any number, no matter how big it is, if we raise that same number to the power of 0, the number will resolve to 1. We have an example here. If we raise 100 to the power of 0, it's equal to 1. If you also raise 1 million to the power of 0, it's equal to 1. Any number whatsoever, once it's raised to the power of 0, except that number is 0, it's equal to 1. So that's the first law. The second law says that if there's any number, we are assuming it to be a here, that a is a placeholder. If you raise any number to the power of 1, that number is equal to itself. So whatever the number is, if it's 1 raised to the power of 1 is 1. 1 raised to the power, 100 raised to the power of 1 is 100, and so on and so forth. So we have an example here, 20 raised to the power of 1 is 20. So if we have a particular number raised to a certain index, say n, and we multiply that by the same number raised to another index, say n. So the result is that number raised to the sum of the two indices, that's n plus n. So we have an example here, 2 raised to the power 3 multiplying by 2 raised to the power 1 is equal to 2 raised to the power 3 plus 1, which is equal to 2 raised to the power 4, and that is 16. The fourth law says that if we have another number, a, being raised to an index n, and is divided by the same number a, being raised to another index n, then that is equal to that number raised to the difference of the two indices. So we have a number here, 2 raised to the power 3, and the same 2 raised to the power 1 is equal to 2 raised to the power 3 minus 1. And that's equal to 2 raised to the power 2, which is 4. So the fifth law says that if we have two numbers, a and b, multiplying themselves, then raised to the power of n. It's the same thing as saying a to the power of n being multiplied to b to the power of n. So we have two numbers, we have a common index, so the first number to the power of n and the second number to the power of n, multiplying themselves. So we have an example here, 2 times 3 raised to the power of 4. That's 3 raised to the power of 4 multiplied by 2 raised to the power of 4. And that equals to 81 by 16, and that's 1296. The sixth law says that if we have a number a being raised to the power, a fractional index, in this case x over y, that results in the y root, okay, of that number a to the power of x. Okay? So at this point you need to be careful to know what is the numerator of that fraction and the denominator of that fraction. Because the denominator will now change to the root and the numerator will change to the index of that number. So that is still equal to the y root of that number all raised to the power x. So we have a number here, 9 raised to the power 2 over 4 is the fourth root of 9 to the power of 2, which is the fourth root of 81, and that's 3. That's a very technical, one of the laws that's very, very technical, and we need to be careful about it. Okay? So the next law says that if we have a number being raised to index. We have here a to the power of n, the same thing as 1 over a to the power of a raised to the power minus n is the same thing as 1 over a to the power of n. So we have 4 to the power minus 2, the same thing as 1 over 4 to the power of 2 is 1 over 16. So the eighth law says that we have a certain number raised to the power, then raised to another power entirely. We now have a to the power of the former index multiplied by the index that is outside of the parentheses. So we have an example here, 3 to the power of 2, then being raised to another power of 3, the same thing as 3 to the power of 2 times 3, which is 3 raised to the power of 6, and that's 729. The least law here says that we have a fraction being raised to a certain power, fraction x over y being raised to a certain power n. It resolves to the numerator to the power of n divided by the denominator to the power of n. We have an example here to illustrate that. We have 9 over 3 being raised to the power of 2, which is the same thing as 9 to the power of 2, and that's divided by 3 to the power of 2. Of course, if we use one of the laws here, you see that this is 3 to the power of 2, or to the power of 2, divided by 3 to the power of 2. We have a common numerator, a common denominator here. So we apply one of the laws here, I think that's law number 4, and we have 3 to the power of 2 raised to the power of 2 minus 2. That's 3 to the power of 2, or raised to the power of 0. And the first law says that any number raised to the power of 0 is that number. That's why we have the 3 to the power of 2, which is equals to 9. With these indices, in our next class we'll be able to manipulate and kind of get a lot of algebraic expressions, simplifying them to their lowest terms. I'm so happy that you've watched this particular video to this point. I believe that you've learned something. I implore you that you should subscribe to our channel, like and share this content. Thank you very much.